Yes, Chris. Can you hear me? Unmute yourself. No, I can't hear you.
Can you hear me, sir?
Yes.
Okay, sir. Let me start my video. 1 second, sir.
Yeah.
It's lagging.
Where the centuries are told or not?
What we had finished in the last class, you remember?
We finished exercise 7, sir. You asked me to do exercise 8.
Okay. Eighth one you did. Remaining two.
Yes, sir.
Okay. So you have to write it in the index form. And we were, this one is remaining, right? Ninth one, the activity. We'll do
1
the act.
second, sir.
Yeah.
1 second, sir.
Yes.
My textbook is in standard form, sir.
It is what? In standard form?
Yeah, so I did in standard form, sir.
Okay, fine. It's
Okay.
tell me the answer. What is for this one?
The first one, it is a y square plus 2x plus 3.
Y square
No,
and
y
2
no y square plus 2y plus 3.
plus 3. Okay, and for second one?
For second one, it is 5x raised to 4 minus 1.
Minus 1. Okay, fine. And last one?
minus 2 r raised to 3
3.
plus cube 2 raised r cube.
I should cube because how many there are? See, 1, 2, 3, 4. 4 there are. So it has to be r raised to 4.
Sure, but minus 2 would become cube, 2 would become square, minus 2 would become 1, and 2 would become 2 would remain
0.
1. 0,
Sorry.
yeah.
Okay, yeah. Okay. So my minus 2 r
2 r
cube
cube
plus
plus
2
2r square.
minus 2 r plus 2. Correct?
Yes.
Okay, fine. So we'll do this activity. We have to classify what type of polynomial it is. First, okay, let's see. First is x plus 7. X plus 7 is what type of polynomial? Is it quadratic, cubic, linear, binomial, trinomial, or monomial? Where should I put x plus 7? How many terms can you see in x plus 7?
2 terms, sir.
So what will
be
it?
binomial.
It will be
Binomial.
binomial. But one more thing.
Yeah.
What is
It's
the power?
also
It is
it's
also
also linear. It's also
linear.
linear polynomial.
Correct. It is also linear. So I'll put it here and here. Okay. Next, x square. How many terms can you see in this?
1 term, so it will be monomial, and it will
Monomial.
also be
Power is 2. So linear,
quadratic.
quadratic. Yes, it will also be quadratic. Okay. Next, x cube plus x square plus x plus 5. Will
It will
this
be
be
cubic polynomial, sir.
cubic? Will it be any one of these?
No, sir.
No, just cubic. Okay. Next, 2x square plus 5x plus
10
10. Now, what will these be?
plus 5x plus.
How many terms can you
It
see?
would be trinomial,
And
and it would be quadratic.
quadratic. Yes, correct. Trinomial and quadratic. Then we have x cube plus 9. So what will
It
this
would be
be?
binomial and cubic polynomial.
Correct. Binomial and cubic. So I'll put it here. And then the last one, 3x square plus 5x. Again, how many terms?
2, so it would be binomial, and it would be quadratic polynomial.
Quadratic, correct. Binomial and quadratic. I'll put it here. So is this clear?
Yes, sir.
Okay, write it down now. You can write it in your textbook itself with the pencil.
Done, sir.
Okay. So that was the last question of that exercise. So now we can move on for the concept to the next exercise. And before that, you need to remember what are coefficients. Okay. If you read the sentence, it says coefficient are added or subtracted while adding or subtracting like algebraic terms. Firstly, what are coefficients?
Numbers which accompany a
Variable.
term, a variable.
A variable that is called a coefficient. So what is the coefficient of this variable x?
2.
2. If I write like this, what is the coefficient of variable x?
7 and 2.
No, x is 7, x square is 2. Coefficient of x is 7 and coefficient of x square is 2. Okay, I'll write one more. 3x raised to 7 plus 2x plus 7x square. What is the coefficient of x square?
7.
Coefficient of x raised to 7.
3.
3. And coefficient of x?
2.
2. Now this one. Coefficient of x cube.
3.
Coefficient of x?
1.
1. And coefficient of x raised to 0?
2.
2. Here nothing means x raised to 0. So you should understand it is 2. But that is not important. What is important is the coefficients. Okay. Now coming back to the statement. The statement says coefficient are added or subtracted while adding or subtracting like algebraic terms. Now, what do you mean by like algebraic terms? Okay, these are two different monomials. Okay, they are algebraic terms. Now, when will they be like? When will they be same?
When they have the same variable.
When they have the same variable, the variable should have same power. Okay, variable should have same power also. Suppose if this is 2x and this is 3x square, these are not like. Okay, they are not like terms. For it to be like, both of them should have same variable and the variable should have same power. Then they will be called as like terms. And like terms, like algebraic terms, you can add. So if you want to add 2x plus 3x, so you directly add the coefficients in front of them. So 2 plus 3, 5. So this will become 5x. But you cannot add 2x plus 3x square. This you cannot add. This is wrong. You cannot add it at all. Understood? You can subtract also, same like algebraic term. 2x minus 3x, you can subtract. So 2 minus 3 minus 5. So this becomes minus 5x.
So can we multiply and divide too?
Yes, you can multiply and divide also. But for multiplication and division, there is no need for it to be like term. Only for addition and subtraction, it has to be like term. Okay. For addition and subtraction. So suppose you're multiplying 2x multiplied by 3x square. This is possible. This you can do. You multiply 2 into 3 first, which is 6. And then you multiply x into x square. How much will it be? X into x square?
2x square.
You're multiplying. Rule of indices. Power gets added.
X cube. X cube.
X cube. X cube. So when you're multiplying or when you're dividing, not necessary it has to be of the same power. Not necessary it has to be like term. But when you're adding and subtracting, compulsory it has to be like terms. Okay, so I'll just want you to write down few notes. Like terms are algebraic term with same variable and same power. Fine, is this clear? Like terms are algebraic terms with same variable, same power.
Okay,
Okay,
sure. Yeah.
and like terms can be added and subtracted. Clear? So to add and subtract like terms, you have to just add and subtract the coefficients in front of them. Okay, to add and subtract like terms, you just have to add or subtract the coefficients in front of them. So I'll write one example. Yeah, I want you to write all these down. So 3x minus 2x will be x, and 3x plus 2x will be 5x. Is this clear? Any doubts in this? So whenever, keep in mind, whenever you're adding or subtracting, they have to be like terms. Means variable should be same and power of this variable also should be same. Write this down. Write it down as note.
Done, sir.
Second point is about multiplying and dividing. So while multiplying or dividing two algebraic terms, we multiply or divide their coefficients and we use law of indices. Okay, so you have to use here law of indices. So for example, I'll take the same example. You're multiplying 3x with 2x. So 3 into 2 is 6. Sorry, at this x square. 3 into 2, 6, and x into x square. So powers get added. So it will become x cube. Similarly, if you're dividing, I hope you remember, powers will get subtracted. So suppose if I'm dividing 2x square with, I'll take an easy one. Suppose you're dividing 8x square divided by 2x. Okay, so this is like 8x square divided by 2x. Powers get subtracted, or you can do normal cancellation. From your 1x and from your 1x cancelled. 2 1s are 2 4s are 8. And we will be left with 4x. Did you understand this?
Yes, sir.
Okay, so you have to keep in mind when you are multiplying or dividing, not necessary that they have to be like terms. You can directly multiply the coefficients and multiply the variable, and you can directly divide the coefficient and cancel the variable. So if it gets cancelled. Clear? Write down the second point and this example also.
Done, sir.
Okay, now let's see how to add two polynomials, how to subtract two polynomials, how to multiply, and how to divide two polynomials. So division is something which we'll see last, because division is a little bit lengthy. We'll start with the easiest one, and let that be addition. Let us add the two polynomials. Add this and okay, let us add these two polynomials.
You said the powers and the variables should be equal, should be like.
Yes, yes, I said that. We'll be doing that only. Look carefully. So the first polynomial, we have to add this polynomial and this polynomial. Okay, so first polynomial 2x squared plus 8x plus 1 with the second one 3x squared minus 4x plus 2. These two polynomials I have to add. So I put this plus sign here. Now, if you notice one thing, I have written it in the bracket. Always you have to put the bracket. The second step will be opening up the bracket. So I just open up the bracket 2x squared plus 8x plus 1 plus 3x squared minus 4x plus 2. Now you may be thinking, what is the use of putting the brackets? Because after removing the bracket, everything is remaining the same. But here, since we have plus sign here, that is why after opening up the bracket, nothing changes. But if you would have had a negative sign here, okay, if you would have had a negative sign here, one minute. Okay. So if you would have had a negative sign here, okay, if you would have had a negative sign here, and then if you open the, when you open the bracket, the polynomial on the, or the terms on this side, all the sign will change. Okay, that I will tell you, show you when we do the subtraction sum, I'll show you that. But when you're doing addition, nothing changes, it remains the same. Now what you have to do is you have to write all like terms together. Now by like terms means you write the x square terms together, you write the x terms together, and you write the terms without the variable together. You write all them together, all of these together. So first 2x square plus 3x square. Second plus 8x minus 4x. And last plus 1 plus 2. Clear? Now we can subtract the, we can solve the like term. So this is 2x square plus 3x square. You can add it. How much will it be?
It would be 5x squared.
Correct. 5x square. Then plus 8x minus 4x. How much will this be? 8 minus 4?
4x.
4 plus 4x. And last 1 plus 2 will be plus 3.
Plus
So this is the answer you get after adding both the two polynomials. Is this clear? Write this down.
Done, sir.
Yeah. Next we'll do subtraction. Now be careful with the subtraction. You have to subtract these two polynomials. So first is 5a square minus 2a minus, sorry, you have to subtract this from this. Okay, this polynomial from this polynomial. So the polynomial after from will write it first. 7a square plus 5a plus 6 minus 5a square minus 2a. Did you understand this?
Yes, sir.
Okay, now second step is opening the bracket. So open up the bracket, first one as it is, 7a square plus 5a plus 6. Now when you open up the second bracket, now since there is a minus sign here, when you open up this bracket, the signs of each term will change. What sign the first term has? 5a square, what is the sign for it?
Plus.
Plus. So when you open up the bracket, it becomes 5a square. Then the sign of the second term is minus. That will become now plus. So plus 2a. So if it is minus, it will change to plus. If it is plus, it will change to minus. Yeah.
So, but after 6, there is a minus already. So minus into plus would become minus, right, sir?
After what? After
6, there is a minus, and 5 has a plus. But so plus into minus will become a minus, right?
minus. Yeah. So the minus sign here. Correct what you said.
Oh.
Minus in plus into minus is minus. So this is the minus sign. If here, suppose if this would be minus, then what would happen?
It would be a plus.
Yeah, then you would get plus here. Okay, but we'll not do that. We'll do it as. Now next is you write the like terms together. So this and this is like term. Then 5a and 2a is like term. But you see there is nothing with 6. So you keep it as it is. So I'll write here 7a square minus 5a square, then plus 5a plus 2a, and lastly that single plus 6 will write it as it is. Okay. So 7 minus 5 or 7a square minus 5a square will be
2a
square plus 5a plus 2a will give you 7a. And lastly, you write this plus 6 as it is. Plus 6, you write it as it is. So this is your answer. Did you understand this? Write it down.
Done, sir.
Next, see multiplication. Multiplication you already know how to do. So this is the easier multiplication. These are just monomial. Multiplying two monomial, this is easier. So you multiply the two coefficients. -2 into 5 will give you -10. And a into a square will give you
A cube.
a cube. So this was easy, multiplying two monomial. But what if you have a binomial and a trinomial? Then how will you multiply? Something like this. How will I multiply this? You remember last time you must have studied bracket to bracket multiplication. Do you remember?
I don't remember, sir, but
Yes.
I
So what we do, what you have to do here is in such type of sum when you have more than one term. So look at the first bracket and look at the first term of the first bracket. It is first m square. So you write m square and you multiply m square with the entire second bracket. So m square multiplied by m cube plus 2m minus 2. Then you look at the second term of the first bracket. It is -5. So you write -5. So first term multiplied with the entire bracket. Again, -5, you have to multiply it with the entire bracket. So m cube plus 2m minus 2. Understood this? Now here you multiply
Yes,
m
sir.
square inside with each term. So m square into m cube will give you
M raised to 5.
m raised to 5. M square into 2m will give you
2m cube.
2m cube minus m square into -2 will give you -2m. Understood? Same thing here. Minus
How minus 2m? So it wouldn't it be like okay, so I understood. It does not have a variable.
yes, it does not have any variable. So that minus sign as it is, 2 as it is. Oh, wait. M square. Sorry, -2m square. Understood? Now, second, -5 into m cube will give you -5m cube. -5 into plus 2m. How much will this become?
10m square. 10m square.
Are you sure m square? It's just 10m.
Yeah, just 10m square. It does not 5 does not have a variable. Yeah.
Plus 10m or minus 10m?
Plus minus 10m.
Minus 10m. And lastly, -5 into -2. How much is this?
10.
Plus 10 or minus 10?
Plus 10.
So plus 10. Now you write all the like terms together. So m raised to 5, it is just 1. So you write it first. Then if you see here, wait, have I done a mistake here? M square into 2m. How much will it be? M square into 2m.
It would be 2m cube, sir.
2m cube. So this is 2m cube here. So 2m cube and -5n cube, write it together. So plus 2m cube minus 5m cube. Then lastly, minus 2m square. There is just single, and even minus 10m is also single. No pair is there with it. Plus 10. So now you have to solve it. M raised to 5. Now 2m cube minus 5m cube. How much will it be?
Three m cube, sir.
Plus or minus?
Minus 3.
Minus 3m cube minus 2m square as it is, minus 10m as it is, plus 10. So this is your answer that you get after multiplying the two polynomials. Is this clear? Write it down now.
Done, sir.
Okay, division we'll do last. We'll start with the exercise. So the first part of this, first question of this exercise is easy. You just have to write letters, write expressions. You have to convert the sentence into expressions. So 3.2, first one. There are 8 trees in the village that if the number of trees increased every year by B, then how many trees will there be after X years? How will you do this? There are 8 trees in the village. Number of trees increase every year by P. then how many trees will there be after X years? Yes.
So would it be addition?
Yes. Initial number of trees. How many it is in the village?
A.
A. So this will be A. Increase
B.
every year. How much is increased every year?
B.
B. You have to find now number of trees in the village after X years. Number of trees after X years. So how much will it be after X years?
A. A plus B.
But you're missing out X years. A plus B is right. You're missing where to put the X.
A plus B multiplied by X.
A plus, are you saying like this or like this? How are you saying?
I meant like A plus B multiplied by X.
First one or second one?
I meant a second one, sir.
Second one is wrong. It has to be first
Oh.
one. Why? I'll tell you that. See. Increase every year. Suppose in 1 year it has increased by B. Then in X years it will increase by how much? Okay. In 1 year you get, suppose 10
Would it be
trees.
B multiplied by X?
Yes, B multiplied by X. So every year Bx is there. Okay, every year there are Bx trees. But initially how much trees were there? Initially X trees. So initial plus number of trees every year. So it becomes A plus Bx. Okay, so this is the answer. This is the answer. Number of trees after X years is A plus Bx. That's it. No need. You don't have to solve anything here. Clear? Write it down.
Done, sir.
Okay. Can you do 2 and 3 for homework? Okay, so 2 and
Okay,
3
sir.
do for homework. And from add the polynomial, do first one and third one. Okay. Add the polynomial, do first one and third one. Other we will discuss later on. Okay.
First one and third one for matter
Yeah.
polynomial.
Yes, yes. Fine. So see you in the next class.
No,